Good day, viewers at home. This is on equations involving indices. How to use the knowledge of laws of indices to solve equations that involve powers. Look at the first example here. 3 raised to the power c minus 1 equals 81. When you have this kind of equation, you try to make the two numbers at both left and right hand side to be in the same base. That is, we'll try to make this 81 to be something in powers of 3. So that will be 3 raised to the power c minus 1. 81. What power will I raise 3 that will give me 81? That is 4. That is 3 times 3 times 3 times 3 will give me 81. So 81 is 3 raised to the power of 4. So when you've gotten the same basis, both in the left hand side and the right hand side, then you equate the powers. So we have c minus 1 equals 4. Therefore, c equals, this will come here, 4 plus 1. So c is 5. This is how to solve this kind of equation involving indices. But when your variable is carrying a power that is in form of a fraction, x raised to the power half equals 6. To remove this half, we multiply both of them by the multiplicative inverse of this half. What do we mean by multiplicative inverse? The multiplicative inverse of any fraction is just for you to change the position of the numerator and denominator. Like the inverse of this 1 over 2 will be 2 over 1. So we'll multiply the two powers, 1 over 2, multiply it by 2 over 1. Then the same thing is applicable here, raised to the power 2 over 1. So that 2 will cancel out 2, then I'll be left with only x. 2 over 1 is 2. This is 6 squared. So that means my x will be 6 squared. That 6 squared means 6 times 6. That is 36. So my x is 36. But sometimes you have this kind of question where you cannot express the larger figure as a power of the smaller variable. For instance, if I have 8 raised to the power x equals 32. 8 raised to the power of x equals 32. What power will I raise 8? That is, how many times will I multiply 8 by itself that I will get 32? That might not be possible for me to get any whole number. So I will try and get a smaller base that is common to both 8 and 32. What do I mean by the smaller base? I can express 8 as 2 raised to the power something. I can also express 32 as 2 raised to the power something. So my 8 is 2 raised to the power 3 x, and 32 is 2 raised to the power 5. 8 is 2 raised to the power 3 because 2 times 2, 4. 4 times 2, 8. And 32 is 2 raised to the power 5 because we have 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 is 32. So we have expressed both of them in the same base. So now that the bases are equal, then the powers are also equal. So we have 3x to be equal to 5. So we divide both sides by 3. X equals 5 over 3. So this is how to solve this kind of equations using the knowledge of indices. Thank you.